Hello there and then welcome to a brand new video. This is Hap Beyond Numbers. We are still on vectors, and this time around we are looking at position vectors and inverse vectors. We need this pre-knowledge in order to study other concepts of vectors. So without much ado, let's quickly look at what position vectors are. When we talk of position vector, the position vector shows the position of a point from the origin. You see, so we say that if a point, so let's just take a point A, which has a coordinate x, y, okay, then its position vector, we write it as O, A. You see, the O here represents the origin, you see, and then its coordinate is going to be x, y. So anytime you see a vector written as this, O, A, O, then the vector name coming, we mean the position vector. That is how far is the vector from the origin. If you look at this Cartesian plane I have over here, this is the origin. Now take note that it is only position vectors that we can also use small letters to represent them. See, so apart from OA, I can also call it small letter A as coordinate x, y. You see, so this is how we represent position vectors. Hence, if you see a vector, let's say on the Cartesian plane, we use this vector over here, and then let me just call it curl. You see, now what is its coordinate? Then what we have here, its coordinate is 3, 4. You see, and as a vector, it is from our origin. You see, so representing it in that way is going to be something like this. You see, hence Q here can then be written in terms of position vectors as either small q, you see, or O q, vector O q, right? So this is something you should know under position vectors. Now let's look at inverse vectors. Inverse vectors. So as the name suggests, if you talk of inverse vectors, it is just the negation of a vector, right? Or turning a vector to the opposite direction. Let's write something. So looking at what we have here, we say the inverse or negative of a vector is the vector in the opposite direction. You see, in the opposite direction. So let's say we have vector AB, you see, which has coordinates x, y. Okay. Now this here would be the vector AB. It means that you have vector A and vector B. And you are moving from A towards B. That is what this notation here. So I'm moving from A towards B. You see, and we just write it as AB, and then we put this arrowhead over here. Okay, so this is its representation graphically. Now its coordinate is xy, but if you want the opposite, or let me say the inverse of it, or the negation of it, then it means you are no more moving from A to B, but rather you are moving from B to A. You see, and moving from B to A is just the negative of moving from A to B. You see, and we know the value of, or the coordinate of A to B. We know that to be x, y. Hence, negating it would then mean that our negative vector, that is from B to A, is then going to be negative x, negative y. You see, now graphically looking at it here, this is what we have. So AB is from A to B, and you can see this arrowhead over here. Now, B to A doesn't change anything. It's actually the same thing we have. So if I'm to put them together, you see, the length and everything are the same, you see. But our arrowheads are different. As you can see from this one, it is pointing towards B from A. This, on the other hand, is pointing towards what? A from B. You see, so these are some few things you need to know under what? Position vectors and then negative vectors. Now you need to remember these as we'll be using them to solve for vector between 2 points. All right. But before we do that in the next video, let's solve some simple examples on what we've done on these. So this first question here says, if A, that is if point A is at 4, 2, you have to find its position vector. So for representation, this is the point we are talking about. So point A, as you see over here, and its coordinates are 4, 2. And since we have to find its position vector, and per our understanding of position vector, then all that they want us to do is to what? Write it as OA. You see, so as OA, we want how far the point is from the origin. And to represent that is just a straight line here. And then what do? We get our arrowheads on the straight line. You see, so the coordinate of it is 4, 2. And that is all. You need no calculation at all, right? And as we have said earlier on, apart from writing it as OA, you can write it as a small letter A. You see, so anytime you see the small letter, it denotes a position vector. Let's look at one question on the inverse vectors. So for this second question here on inverse vectors, now I've taken time to do the graphical representation here, which I would explain. It says if PQ, if you're at P, and you're moving towards Q, you would have to move what? To the left 3 times. You see, you'd have to move to the left 3 times and then move upwards 5. Or in other words, move 3 times towards the left in the X direction and then upwards in the Y direction. Move how many times? 5 times. Now then we have to find how long we are going to move towards P when we are at Q. You see? Okay. So graphically, this is our P, point P here. And then this is Q. So if I want to move to Q, then I have to move 1, 1, 2, 3 towards the left hand side. That's why you have -3. Then at this point, I have to move up. So 1, 2, 3, 4, 5. You see, that is how come you have this 5 over here. Then if I want to move, if I'm at Q and I want to move to P, I'm just going to move 1. So we move first in the X direction, right? So I'm then going to move how many times? 1, 2, 3. You see, if I move 3, I'm in line with Q. So it means that after moving 3, I'll then move 1, 2, 3, 4, 5. You see, and that will bring me perfectly towards my point P. But to solve it without the graph, then our KOP is just the negation of PQ. You see, and we know what PQ is. So negating it then means we have a negative of -3 and negative and then 5. And we know this negative affects both. You see, so that we are then going to get a +3, then a -5. And just as we said, +3 means you are moving 1, 2, 3. You see, then the -5, you are coming down. How many times? 5 times, right? So that will be it for this lesson under position and then inverse vectors. I do hope the explanation was clear and then you have also learned a lot. See you in our next lesson where we look at the vector between 2 points. Bye for now and then stay safe.